Namaste one and all. This is Vijay Krishna, Assistant Professor in Mathematics from Applied Sciences and Humanities Department, Shashi Institute of Technology and Engineering, Tadepalligudem. So today I am going to share my knowledge regarding gradient. So what is gradient? What is the definition of gradient? See this is the welcome slide. DGVC today we are going to class a DGVC class. Particularly the topic is gradient. Okay. So see the definition of gradient. Phi is a scalar point function which is in terms of x, y, z. Okay, so then gradient of phi is denoted as grad phi or del phi. Okay, grad phi or del phi. Okay, so grad phi or del phi is defined as sigma or summation I bar dou phi by dou x. When we expand the summation, we get I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. Okay, so this is the definition of gradient. Once again, gradient of phi, that is denoted as del phi or grad phi. Okay, so del phi sigma I bar into dou phi by dou x. When we expand the summation, I bar into dou phi by dou x plus j bar into dou phi by dou y plus k bar into dou phi by dou z. So this is the definition of gradient. Now we will see the properties of gradient. So these are the properties. Here f and z are two functions. Okay, then del f plus z equal to del f plus del z. Right? Del f minus z equal to del f minus del z. Right? So by particularly del f plus or minus g equal to del f plus or minus del g. Right? So now del fg, f into del g plus g into del f. Okay, so this is a derivative of uv form. Now del f by z, g into del f minus f into del g whole by g square. So we know that the derivative of u by v, so by the same form vu dash minus uv dash by v square. Similarly g del f minus f del g by g square. Okay, so next one, del of cf. Here what is the c? C is a constant. So when we calculate the del of cf, simply c take outside and calculate the del f. C into del f. Okay, so these are the properties of gradient. Now coming to the problems. Now here the problem is find the gradient of phi, x square y plus y square x plus z. Okay, at a point 1 comma 1 comma 1. So when we observe the given problem, here given one scalar point function, that is phi equal to x square y plus y square x plus z, and also given one point, that is 1 comma 1 comma 1. So coming to the solution, first we have to take given scalar point function, that is phi equal to x square y plus y square x plus z, and also take the given point, that is 1 comma 1 comma 1. Okay, so this is the given. One is a scalar point function, another one is a point. Okay, now if you want to calculate the gradient, first we have to calculate the partial derivatives of phi with respect to x, y, z. So first one, dou phi by dou x. How to calculate partial derivatives? We know that partial derivatives, when we differentiate the partial derivatives with respect to x, treat the remaining two variables y and z are constants. Okay, so here x square y, in x square y, when we differentiate with respect to x, y is a constant. Take outside y, remaining x square. What about the derivative of x square? We know that derivative of x square is 2x. So 2xy. Okay, plus here the term is y square x. In y square x, y square is constant. Take outside y square. Remaining x derivative 1. Right? Now, next term is z. Derivative of z. When we differentiate with respect to x, the remaining two variables, both y and z are constants. So the derivative of z is 0. Right? So this is dou phi by dou x. Now calculate dou phi by dou y, partial derivative with respect to y. So when we differentiate with respect to y, remaining two variables x and z are constants. So in the first term x square y, x square is a constant. Take outside x square. Remaining y derivative 1. plus next term is y square x. In y square x, x square x is constant, take outside, remaining y square derivative 2y. So 2xy. Next term z. Derivative of z with respect to y is 0. Right? So now calculate dou phi by dou z, partial derivative with respect to z. So when we differentiate with respect to z, treat the remaining two variables x and y are constants. So here when we observe the phi, the first term is completely constant. Why? Because it is x square y. Both x and y are constant. So derivative of x square y is 0. Next one, y square x. Here also the term without z. So it is completely constant. So derivative is 0. Next, the last term is z. Derivative of z, 1. So dou phi by dou z equal to 1. Okay. Now, write the formula for del phi, grad phi. Okay. So, grad phi, that is del phi, formula sigma I bar dou phi by dou x. When we expand the summation, we get dou phi by dou x into I bar plus dou phi by dou y into j bar plus dou phi by dou z into k bar. So, substitute all values. Dou phi by dou x. Dou phi by dou x is 2xy plus y square into I bar plus dou phi by dou y, x square plus 2xy into j bar plus dou phi by dou z, that is 1 into k bar. Okay, so this is a grad phi, but we want to find the gradient of the given scalar point function at the point. What is the given point? 1, 1, 1. So now calculate grad phi at the given point, that is P. Take this point as P. Okay, now grad phi at P. Substitute the values x, y, z. All are equal to 1. Then 2 into 1 into 1, 2. Plus 1 square, 1. 2 plus 1, 3 I bar. Similar, 1 square plus 2 into 1 into 1. Total 3 z bar. Plus there is no x, y, z. So k bar. Finally, we got grad phi at point P equal to 3 I bar plus 3 z bar plus a bar. So this is the way of calculation of gradient at the given point. Okay. Now coming to the next problem. Prove that del r power n equal to n into r power n minus 2 into r bar. So in previous problem, given one scalar point function and given one point. Okay, but here there is no scalar point function, there is no point. Here we want to prove one equation, that is del r power n equal to n into r power n minus 2 into r bar. So if you want to prove this, first we have to take r bar. What is r bar? R bar x I bar plus y j bar plus z k bar. Xi bar plus yj bar plus zk bar. Okay, then we know that mod r bar, that is root over x square plus y square plus z square. Okay, now squaring on both sides, then we have r square equal to x square. When we are squaring on both sides, the right hand side root is root over x square plus y square plus z square. Whole square is nothing but x square plus y square plus z square. Okay, so finally we got r square equal to x square plus y square plus z square. When we observe the equation, clearly r is in terms of x, y, z. Okay, now differentiating with respect to x, y, z. With respect to x, y, z partially. Okay, so we know that how to differentiate partially with respect to x, with respect to y, with respect to z. So first with respect to x. Now the left answer is r square. Derivative of r square 2r into inner derivative r dou r by dou x equal to right hand side. When we differentiate with respect to x, remaining two variables y and z are constants. That's why derivative of y square, derivative of z square are zeros. Only we have left right hand side x square. The derivative of x square is 2x. Okay, then both hand side to cancel. Then here r is multiplying on left hand side. When we move to the right hand side, it will divide. So finally dou r by dou x equal to x by r. Dou r by dou x equal to x by r. So by similarly differentiating with respect to y, we get dou r by dou y equal to y by r and dou r by dou z equal to z by r. Okay. So finally we got dou r by dou x equal to x by r, dou r by dou y equal to y by r, dou r by dou z equal to z by r. Now we have to prove the given del r power n equal to n into r power n minus 2 into r bar. So to prove this, first we have to take LHS. Okay. So what is LHS? Here in the given LHS is del r power n. Del r power n. What do you mean by del? It is nothing but del phi. So we know that the del phi definition, that is sigma I bar dou by dou x of r power n. So by the definition of gradient, we write del r power n as sigma I bar into dou by dou x of r power n. Then sigma I bar into dou by dou x of r power n, derivative of r power n into r power n minus 1 into dou r by dou x. Okay, then here n into r power n minus 1 into what is there? Dou r by dou x. So dou r by dou x is, we know that dou r by dou x is x by r. Okay, already we proved that dou r by dou x equal to x by r. So we substitute dou r by dou x value here, then we get sigma I bar n into r power n minus 1 by r can be written as r power n minus 2 into x. Okay, so here n into r power n minus 2 is constant, take outside, n into r power n minus 2 into balance sigma I bar into x, sigma x I bar. What is sigma x I bar? X I bar plus y j bar plus z k bar. So what is that? X I bar plus y j bar plus z k bar? That is nothing but r bar. So n into r power n minus 2 into r bar, nothing but RHS. Okay, so finally we prove that LHS equal to RHS, that is del r power n equal to n into r power n minus 2 into r bar. Okay, so this is the problem. Now coming to the next problem, it is also similar problem. Show that del f of r equal to f dash of r by r into r bar. Okay, so if you want to show the given equation, first we have to take LHS, that is del f of r. Okay, so we know that del f of r, it is in the form of del phi. We know that the definition of del phi can be written as sigma I bar into dou phi by dou x. So dou by dou x of what is phi here? F of r, right? So then sigma I bar into dou by dou x of f of r, derivative of f of r, f dash of r into inner derivative dou r by dou x. Okay, then sigma I bar f dash of r into what is dou r by dou x? Already we explained dou r by dou x calculating in the previous problem. Dou r by dou x is nothing but x by r. Okay, so when we observe the summation, in the summation f dash of r by r is completely constant, take outside. Then f dash of r by r, take outside, remaining sigma x into I bar. Okay, so then equal to f dash of r by r into expand the summation x I bar plus y j bar plus z k bar. We know that x I bar plus y j bar plus z k bar, that is nothing but r bar. So really it is RHS. Okay, now we have to prove that LHS equal to RHS, that is del f of r equal to f dash of r by r into r bar. Right, now coming to the assignment. So this is your assignment. Find gradient of x square plus y square z. It is the same model of first problem which is explained in the class. Now find the gradient of phi where phi equal to xyz. This is also same model problem. Okay, so we have to do this assignment and submit. Okay, thank you so much. Thank you.